Good morning, good afternoon, good evening. Happy Friday to you all, RAKStars. Welcome to our weekly session of Hands with RAKstar. For those who are joining for the first time, this is just a community space where we share with passionate RAKStars to talk about their experiences, their journey, as well as some contribution they have been making to our community. I am Maria Hernandez, Developer Relation Lead at RAK, and next to me, Jose Marcelino.
Hello from fake Greece today, just to be different.
Yeah, and yeah, in today's session, we're going to be chatting with an engineer who have a lot of years of experience working with several companies, and also he has a lot of experience working with different IoT technologies. Who have been joined in the past session, and we have learned a lot from him. Today, we're going to be chatting with Paul Pinault. Paul, welcome to the stage.
Hey, hello Maria, hello Jose.
Hey Paul, hello again. Another session today.
Yeah, I think this is the third session that Paul has with us.
Yeah. He always has something new, so it's fine. It's good.
Yeah, exactly. First time, figure stack migration, B2 to B3, then a round table about Helium, and it was super funny because that just was like a few weeks ago. And I remember that for that day, we were talking about 20,000 hotspots, and we are right now in more than 50,000. So it's, 50,000. It is huge numbers.
50,000.
Yeah.
Incredible. So,
basically incredible.
Yeah. So for those who are connected, like as every week, if you have like any questions about everything that Paul is going to be sharing with us today, feel free to ask any question in the comment section, and we'll be happy to address them during the conversation if it's appropriate. If not, we can leave them for later on the Q&A session. So we already have like the opportunity to chat with you in previous session and know a little bit more about you and all the work you have been doing and all the contribution as well. But for those who are just watching it for the first time, can you share just a brief introduction about yourself and about the things that you have been doing during the past years?
Oh, sorry. Yeah, for sure. So what I'm doing basically, I'm blogging a bit about IoT. I like to talk about what is currently on the news. So what is moving really fast in IoT domain, basically. So currently I'm talking about Helium. But I also work a lot on Sigfox technology 5 years ago. Also work a lot of about LoRaWAN and TTN by the past also. And I'm starting to take a look and to talk about Kineis, which is a satellite solution. I love all the technology around IoT and try to explain how they work, how we can use it in simple words, and try to see what could be the use case and how it could be used in the companies to make this. I'm also developing some code, open source code. So I have a SDK and around it for IoT, which is in my GitHub. I have some cool projects currently, like this field tester that allows to test LoRaWAN and a Helium network and to map it to get the coverage information and stuff like this. So it's also open source and low cost. And maybe, that's basically a part of what I'm doing.
Actually, like an important thing to highlight over here is that Paul have a blog, a tech blog, where he share his brain with all of us about all the things he has been thinking with and exploring with all the different technology devices. And it's pretty cool because he's super technical and super detailed with each of the steps that you need to cover or learn about the different technologies that are relevant right now in the IoT ecosystem. So I fully recommend you to check out decide to learn a lot about IoT. So yeah, now today we are going to be chatting about Helium itself.
Yeah.
And as someone as like that as someone which is like super involved in the IoT ecosystem more than other communities such as, for example, blockchain and crypto, that are some communities that are mixed in the Helium community. What are the advantages and the benefits from working from Helium for your LoRaWAN projects over other services you have been using in the past?
Yeah. So in my point of view, what is really interesting with Helium is the growth and the size of this network. So that's really important because LoRaWAN is a really interesting technology, but it has been created by operators. And that's a big issue, basically, as a telecom operator are basically nationwide organization in most of the case. Even when you have companies that are international, it means basically they have different countries where they're operating national system. And that's a big issue in the telecom domain and mostly in the IoT domain. It's because you have to manage subscription in different countries. So you can work with NVNO or people like this that are trying to negotiate with a different operator and propose a global coverage. But it's always complex. You have to manage eSIM, you have to manage subscription really expensive in some countries and so on. So that's a big issue. And as LoRaWAN has been deployed by telecom operator, basically all this complexity was part of the LoRaWAN ecosystem. And so that was really interesting to see some people trying to create something global and out of the telecom existing systems. And that, the first one that made that was the Sync network. So they start doing this 5-6 years ago, and they did something really great. With they have something like 17,000 gateway deployed, plus the one they have deployed with the Sync industry. So it's something like 30,000 gateways deployed on the world. And that's the beginning of a global network for LoRaWAN. But this network is really good, but it addresses hackers mostly for the growth and IoT addicts, which is a small ecosystem. And the curve, it was growing really fast at the beginning, and it reached a plateau. And it was really difficult to think that this network can cover the whole world. And what with Helium is interesting is that by adding money in that system and creating a way, transforming the deployment of network into an investment, it creates a crowdsourced network with basically a crowdsourced invested network with a size which is totally different compared to what we have seen before. And basically today we just say that there are 50,000 gateway deployed in the world. It makes it in less than a year the largest network in the world in terms of gateways. And today we know that we are about 10% of deployment of what have been ordered, or more, or maybe we are less, but we know that 10 times more is coming for the next year. So it's already the biggest one, but it will be something really huge. And so it makes a reality of having an IoT global network. And so it totally disrupts the telecom environment, which was nationwide with problem of subscription, roaming complexity, and so on, to make one big global network. And in terms of application, as a device maker, I'm also do device, and also a service provider, basically. So I'm doing device, but I also provide the service on top of the devices. I don't want to have managed my subscription with different people. It's already a mess when I have one company to negotiate with. So if I have 10, it's just impossible. So I want to have something really simple, and I want to have something worldwide, because my experience on 5 years developing services on IoT is you do 5% of your business in your local country, and you basically do 5% of your business on any country. So your 100% of business about 20 different countries. So if you want to be efficient, you need to have no boundaries for your devices and for your services. And that is something that Helium is providing, and for that reason, it's something really interesting and something new, disruptive, basically, which is quite important.
Yeah, completely. Actually, like there was a tweet today from one community member that he says like, okay, I don't like to be part of the community network because every time jumps one guy asking if this device can mine HNT. And he was like worried about that. But if you think it in another perspective, it's like, okay, in some way, there are people that are not directly related with IoT, but they're helping you as an IoT developer to create a crowdsourced network to be able to deploy your solution as well. So yeah, it is a win-to-win for everyone. I can say.
Yeah, and I mean that's something I also think really interesting with Helium. I mean, it's not Helium itself; it's a Helium movement basically. In IoT domain, we really suffer since 5 or 6 years of a problem of maturity. And all the IoT companies, they are doing POC and POC and POC, proof of concept, proof of concept, proof of concept. It's never go in production with important volume. And generally, it's not I never heard that it's a problem of technology. It's always that we had in terms of business, we had a good idea. We have tested an IoT solution for responding these ideas, but these ideas, okay, we don't really understand how it can transform our business and how we can really create value. So it's always a cost and not something sufficient to go in production and so on. And this is not a problem of technology. It's not a problem of creating value. In fact, it's just a problem of maturity. I mean, understanding at scale what this proof of concept can become and how it can transform the company business. And this problem of maturity can only be addressed in a way. It's basically training many people on what is IoT, what we can do with that, and so on. And with Helium, as the community is not tech, I mean, it's 95% or 85%, something like this, of people that are totally out of the IoT space. They are more involved in cryptocurrency. And cryptocurrency touch any kind of people. I mean, there is financial people, there is technical people, there is managers, there is, I don't know, anyone can be part of this. And what I see in the community is I see a lot of people that have been never understand and hear about IoT that start to understand what it is, because they want to understand. I mean, some are just investing and making money, some of them, but most of them say, I deploy a network, but what is this network? How can we use it? For what application? And so on. And so those people are gaining maturity. They won't be IoT developer, it's not the idea, but they start having ideas. And I had a lot of questions of people saying, oh, with this solution in my business, could I do that? Sometimes the response is not, yes, you can do that with Helium. Sometimes the response is, you can do that with, I don't know, GSM or with another way. But they start thinking about application and use cases. And so, I mean, if we have 500,000 people in the world that have understood what is an IoT project, what we can do with it, what is the value we can have for the company, and if these people have also a personal interest in developing the solution because they will earn HNT with that, it can transform lots of proof of concept to deployment. And I think that we can have a gain of 2 years in terms of maturity. That's, I mean, 2 years is just a personal estimation, right now estimation. But basically, we can have a gain in terms of maturity for the IoT, and that's really interesting. And that's interesting for Helium, but also for other LoRaWAN technology, for Sigfox, for basically for all the IoT domain and for the industry using it. So that's quite interesting also.
Completely. Actually, like the growth and the traction of this technology, like in the ecosystem, have had a significant impact on the companies who have been working with LoRa and LoRaWAN technology in the past. and that is why today we can see the arrival of new hotspots for Helium, and also the approval of new manufacturer who will be developing hotspots in the future. As you mentioned at the beginning, like today we have 50,000 hotspots, but we know that this is going to be much more in the future, right? So it's something that is super important to mention over here, and it is like how to choose like the best hotspot in some way. So I would like to hear from you, like what are the key characteristics in some way that you consider to choose the right hotspot for your deployments?
Yeah, the best hotspot today is the one you can have at home in the shortest time as possible. So what I mean, it's complicated to say that to discuss of this topic here with you as your rack, because if I say that the best one is rack, no one will trust me. And basically, I mean, currently it's my favorite. To be honest, it's not because you invite me, but yeah, I like the rack solution for at first because they are delivered. The first one I ordered, I wait a lot of time to get it, but I've ordered 5 of them, I think, 5, and I will get it now. So. Actually, currently, I mean, I've ordered one and another one 2 months after, and another one 3 weeks after, and 2 of them 3 weeks after, and I receive them basically every week currently. So
That's nice.
I have a plan. I'll spend all my weekend deploying getaways right now.
Send us picture, please, and video.
Yeah, I have some nice picture. I'm going this on Monday. I'm going to deploy on top of a mountain. That's really cool. So I mean, currently I'm following the hotspot market right now since a while. My computation made you about 76% of the market share currently. So RAK is the first in terms of hardware deployed in sales, and if I deployed and in sale, I don't know, but deployed for sure. And the production, the delivery rate, I don't have the last numbers in mind, but it's something around 500 per day. Which is basically about 10 times what the competitors deliver. So I mean, either if you have a big backlog, basically, in my point of view, RAK is the one that is able to fulfill the backlog in a short time, which is quite cool on this concept. So that's, I mean, currently the reason why RAK is my favorite. But technically speaking, I mean, RAK is also, in my point of view, the most mature, because I mean, it's just your business since 6-7 years at least. I mean, and I as I say in a previous talk, I was not a big fan of RAK by the past. For one reason is that, I mean, your hotspots were more concentrator card on a Raspberry Pi, and mostly of the installations that were made by TTN people were using a Raspberry Pi. And I mean, I prefer to have a low power solution, like doing the solar gateways and stuff like this. And so, in my point of view, it was too large system for running a LoRa gateway. But I mean, for Helium is what is needed. So I mean, what I was considered as something a minus by the past in a LoRa environment is for Helium a plus, because you have the experience of building such system. And I mean, it's what we see when we manipulate the device. I mean, the box is really cool, fitting well with the Raspberry Pi. The heat is really correctly managed inside the device, and so on. So that's a perfect miner, basically, well finished, and so on. I do not. I mean, currently I just have 2 different brands in my hand, so you're my favorite on 2 currently, which is very bad. But that's quite cool. I just have a problem with the Wi-Fi solution, but I mean, it's you have to deal with Raspberry Pi 4, so and so on. So
the built-in antenna.
Yeah, it's a bit a problem for some people. Yeah. But yeah, so you happy with my answer? you get my answer?
I'll send you the HND later then.
I was not ready for that question.
Can you show the QR code of your wallet on screen now so we can send it?
Sure. That's a hotspot.
Okay, so now it's like jumping to what we came to talk about today exactly, which is building private networks on top of the people's network. Why we should create these private networks on top of Helium, and what difference does this deployment have in comparison with the common deployment?
Yeah, so that's the second point I did not yet notice about Helium, which in my point of view is the main differentiator with any other LoRaWAN network, and that's made something really disruptive with Helium. In a classical LoRaWAN network, you have gateways, and all these gateways are end-to-one to a network server. So all the gateways have a single network server. And so it means that all the traffic is routed to a single point owned by someone. And in LoRaWAN, the encryption is from the device to the application server, but in fact, the application server for real is in part of the network server. So basically, the payload is encrypted from the device to the telecom operator. And the keys are distributed by the telecom operator. So it means that your data is not safe, basically. If you don't implement something specific in your device, so basically if you buy a device from the market, your payload is not encrypted at the network server. So if there is an attack on the network server, or if the network server is not someone you trust, because this network server is for a foreign country, for example, and your data is a bit sensitive, like health data or things like this, it can be a problem. And basically also, as you have a network server, you pay to that network server for the subscription for the communication. So what is different with Helium is that in a Helium network, you have gateways, you have different network server. You can have as many network servers as you want. And the payload can be received by any of the gateways. So you have a worldwide network. And this payload is received by one of the gateways and transferred to the right network server, which is named the router in the Helium naming. And so it means that only this router is able to decrypt the information. So the information is encrypted from the device to the router. And in Helium, you can be the owner of your own router. So anyone can have a router, and it means that the payload will be encrypted from the device to you. So that's the difference. There is no one knowing the encryption key other than you. So that's something really interesting. And that way, and what is interesting is that for doing this, you don't need to have any negotiation with anyone. You just have to create a transaction on the chain to create to register your router, basically, and you deploy your software, and you have your router which is in place. So you don't need to have a request to someone. You don't need to negotiate anything. You can, on your own, create this router and have your payload directly routed. So that's interesting because Helium is an American company, which is not a bad thing. But in terms of data sensitivity, it's not really good if you are a European company or an Asian company to have all your data passing in North America because they have some law that allows the government to access to the data that are transiting that way. And if you are doing an application like industrial application or like health application, you also have rules in your country, generally locally, to protect this kind of information. So thanks to this router technology, if you have a service provider in health, you can deploy your router for your application, for your service, and the data will never go to the North America. Just if the sensor is in North America, it will pass through the network. But I mean, the data will stay locally. If you are in France and your service is your device is in France and your service is in France, basically it will be the route from the gateway in France to the router in France, and it will never go away. So you can respect the rule like this. You can protect your data like this. You ensure that no one can access this data. And in terms of subscription, basically, you will manage this subscription at your router level. So basically, you have one big wallet in your router, and all your device will use that wallet to pay in DC the communication to the different gateways. So that's quite simple. You have no one in the middle, just the blockchain, and that's cool for this kind of application. Is that clear?
It's completely clear. It's completely clear. And actually, like one important thing to mention over here is like, what are like the costs involved in deploying these private networks?
I'm sorry, I didn't capture your question.
What are the costs involved in deploying a private network?
Yeah. So to deploy a private network, basically you need to buy on the chain an OUI, which is just a number saying I'm the router number 5, number 6, number 7, number 8, and so on. Okay. So it's your identity of router, and you pay $100 for this, or you pay in DC, but I mean it's $100. So it should be something like 10 million DC or something like this, if I'm not wrong. I have some. It's hard to convert the DCs in dollar.
I agree.
So let's talk in dollar. That's another thing which is really clever in Helium is, I mean, all the transactions related to the business, the IoT business, are in dollar and are they are stable. And so you know that the price is the price for this way. It will be the same price in 10 years. And so you can incorporate this cost into your business model. So that's really quite cool. So $100 for the OUE, but then you need to have another thing, which is a device address. So every time a device is joining the network, you need to make a join request and get a join accept. And in the join accept, the device gets an address for the running session. And the number of address all over the network is 32 bits. So basically, there is 4 billion of addresses that can be shared. So it's quite large, but we can have a limit at the end with that. And so you have to pay for this resource. And one address is also $100, basically. So you need to pay for a minimum of 8 addresses. So the minimal cost to get a router is $900. So now you should say, okay, if I have 8 devices running, I have to pay for $800. Wow, that's quite expensive. So keep cool. In fact, what is interesting is an address can be easily shared between different devices because, in fact, all the traffic is encrypted from the device to the router. And if you, for the same address, if you distribute different encryption keys, it will be easy to identify when a message arrives who is the real owner. So, in fact, the address is something that is, I mean, we don't do anything with the address, basically. It just filters the choice of the decryption. That's quite interesting in LoRaWAN, because if you see LoRaWAN today, I love this protocol. I'm just going to be bad with LoRa Alliance a bit. I love this. I'm quite sure that the guys who have written the LoRa specification, they are doing it after a big lunch when they are totally drunk. I see no other reason to have made this thing. I'm sorry. you guys. But what you see today is to register a device on a network server, you need a dev UI, you need an app UI, you need an app key. And currently, we know that dev UI and app UI has no interest, basically, because we so now we put the same for both. So you just use Flash for pleasure of this. Then you have port for the communication. It just consumes 8 bits in the payload. In reality, have no interest in 99% of cases, just for the big, the complicated network communication, but 1 bit would have been enough. And so that's clever. That's quite fun. And now we have the IDs, and we see that most of the operator TTN do the same, and do the same. They are multiplexed thanks to the encryption things. So I mean, it's the device ID still makes sense to. Otherwise, the search for the device would be too long if based on decryption system. But it's quite funny. I mean. Sometimes I say that 20 bits or 10 bits could have been enough that way. Oh, by the way, I close my parenthesis. So basically, what does that mean? That means that with eight device address, you can address about 100 or 200 devices with no big difference. So 200 devices running in parallel on your system. Maybe more, I don't know, maybe Jose, you have a better idea of the maximum number we've seen, but I think we can be a bit large.
Yeah, I think you can be go to 1,000 easily as well.
Oh yeah, 1,000. Okay.
Yeah, there's no real limit. I think it's just the processing that you need.
Yeah, it's more the computation. Because in fact, what happened is when a frame arrives, it arrives with, I don't know, device address 1. And so you have to request your database, all the devices that have the address 1, and you have to try to verify the signature for all the addresses until you get the right one. So if you can execute this process in a few milliseconds, you can have 10,000 basically.
Exactly.
But if you need 1 second to do that, it's going to be a problem because you have to respond to the join accept in less than 5 seconds. Yeah. So you need to manage that. And for it's not only join accept, it's also it's more for the acknowledgement, and you have 1 second to respond maximum. So it can be a bit challenging. So you need this addresses, so you can go to 500 to 1,000 maybe with that, and so basically you have a cost of 900 euro to be your own the owner of a router, which is I mean, with 900 euro, I don't know what is the price for the network server at RAK. i3, sorry. But if you ask for a network server to a company that is specialized on this domain, it's really more expensive than.
I mean, the service is similar to the things industries, like because you can run private servers on the things industries using the things network, public network. So it's kind of like a new way of doing that, I guess.
Yeah, and it really makes sense. It really makes sense. Basically.
Yeah, and it's expensive. TTI is expensive, so I guess it's 900. It's not it's kind of the similar thing.
Yeah. Okay. So once you have done that, you need to host the router. So you also have some cost to have your own server running this software. You also have to update and manage this software. So I mean, the initial cost of 900 euro is not something really high in the total cost of ownership, as you need to maintain a server. It's not a big server, basically. Here, I mean, for tests, we are running on a 4 virtual CPU and things like 8 gigabyte of RAM. So it's really a standard VPS. After it depends on the number of devices you have, but it's not consuming a lot. And then you have to pay for transaction. I mean, there is also on the chain you need to pay for different things when the system is the router is running. There is quite a lot of things, in fact. I mean, when in Helium we say a message costs 1 DC, in fact, it's not true. It's true in console.helium.com because, in fact, Helium is paying for the rest. So it's quite, I mean, they are paying a lot, in fact, compared to the price of the communication itself. But if you own your router, you have to pay for different transactions. For example, every time you add a device in the chain, so you create a new device with its dev AEI and app AEI, you have to register it. I mean, your router has to say to the chain, this device is one of mine. And this is a transaction on the chain, and I don't remember, it's something like 45,000 DCs or something like this. It's not a big cost, but if you have 100 or 1,000 of device, it starts to be a lot. And for real, you don't pay per device. In fact, you pay per transaction, and on a transaction, you can declare 100 device if you have. So the cost of this depends on the number of transactions you want to have. If you are a public console, you will have device register every 10 minutes or 15 minutes, so you have to pay a lot of transactions. If you are a service provider deploying 1 million devices, you can declare your 1 million devices in one shot, and so you have only one transaction basically. I don't know what is the maximum number of devices you can have in a transaction, but that's the idea. So that's one thing you pay for. And there is another one, which is a states channel. So that's another concept we don't manipulate a lot when we are mining HNT, basically. In fact, there is some micro blockchain that are created at the router level to discuss with the gateways, because basically we don't want to have in the main blockchain all the information about packet transfer, because there are too many, and the blockchain will explode in terms of size if this transaction would be included in it. So a short time blockchain is created at the router level, which is a state channel. And this state channel is in a link with the different gateways. And basically how it works, when a hotspot received a message from a device, this hotspot creates an offer to the router. So the router received offering from different hotspots receiving the same message, and the router will select one of them or two of them, depending on the setting you have made, and it will decide to pay for one. And the state channel will register this transaction. And so in the state channel, you will have all the history of what hotspot has been received the packet and has been paid, that will have to be paid for this transaction. So the state channel have a duration. It can be 1 hour or it can be 1 week. For example, the Helium is really a short duration state channel. So that's why when you have a packet transfer on you, you will see packet transfer activity in your hotspot activity on every hours, basically, which is interesting in terms of monitoring, basically. But if you do that, you will have to pay. I don't remember, but it's quite expensive. I don't remember the value in DC. It's quite expensive, but you mean that every hour you're gonna have to pay for a state channel opening transaction. And so the running cost of the router can be really high. And so this is something you can tune. And for a router you deploy, you can have a state channel duration of 1 week, which is what I'm doing on the one I've deployed, for example, 1 week, which means that the transaction will be accumulated in this state channel. And after the week, when the channel will be closed, we're going to have the packet transaction appearing, and in the activity in terms of reward, all the transactions from that week will be paid to the different hotspots that have received the information. So that's something you can parameter and deal with to optimize your router cost. And so that's the main element of price in the router environment. Read my blog post about this, because there is lots of detail and the complexity is a bit higher. I also made an Excel spreadsheet, a Google spreadsheet, where you can enter your settings, and it gives you the real cost per communication. So you will see that it depends on your concept configuration. at the end, for one message going out of your device, it will cost 3 DC, 5 DC, 4 DC, 1 DC point something, and so on. So that's interesting if you want to go to that business to really calculate the cost of your subscription-like solution. And one thing which is important, because I had this question a lot of time before, is does the device own a wallet to pay the communication in DC? And that's not the case. The device don't pay for the communication. As I explained, the communication is a negotiation, a contract between the hotspot and the router. So basically, it's the router that is paying for the communication of a device.
Of course.
So when you have a wallet on console.helium.com, in fact, it's just a fake wallet. In fact, it's just a router wallet, so the Helium wallet, which is used to pay the communication, and you have a share of this wallet, basically. And so in that area, what I've done, I mean, I explained that I've created a router. This experience is also describing the same thing. I have another blog post which is presenting all the steps to create your own router. Wow, you're quite efficient. You're well prepared. So you can see all the detail on this. And as you will see, it's not something really simple. And I mean, it's not super complicated, but it's not super easy. And moreover, you have to maintain all of this. And at the end, it's not IoT stuff. It's not electronic. It's basically operating a solution on a computer. So it's basically a cloud-based activity. And so, as you see, we think it's really interesting, and many routers could be interesting to be created for different service provider and so on. So we have decided in my company to create a service to do a router as a service. So basically, if someone needs for his service or for operating in his country, because it's also interesting to have data not route to different countries or directly for us given services, we are able to instantiate a router, a private router, for a specific usage, specific country, and so on. And we operate this kind of router. So this is what we do in a service which is named Helium IoT.eu. And so if people are interested, we can do some cool thing around this topic.
Cool. And like the name says, it's based in Europe, right? So you can you don't have the European laws. You can run within all them. So
After we can deploy in different countries, but I mean we are located in France, and basically we are a cloud provider, sovereign cloud provider. So we can do cool thing, and particularly, I mean, if there is health application, for example, we are certified for managing health data, so we can.
Oh wow! Okay,
amazing. Nice. Really,
and do you already have some projects going on with IoT, with Helium IoT EU?
Not yet. I mean, we are really in advance. I mean, the market is. I mean, currently Helium is growing the network. So at first, it is a network to be deployed, but we would like to be ready for that. So we create the offer. It's not our main activities. I mean, it's 0.00000. It's like the DCs in terms of market share for us. And so the idea is to test the market, to show that it's possible, and being able to do that. And we'll see if some people is interested in such solution.
Completely. And what are like the applications you are currently addressing on top of the People's Network, based on your previous expertise in LoRaWAN projects?
I mean, currently, I have tracking application, but there are more application for mapping currently. That, I mean, when you're deploying a network, you want to see where the network is working and so on. Currently, I mean, at least in France, the coverage is limited in terms of number of cities. It's growing really fast, but it's a bit limited. So it's more application for the miners themselves to monitor the network and to cover to measure the coverage. For this, I have two projects. I mean, I don't have my ping there, but I have a really small device. We're just sending a frame every 15 minutes. And the idea is just to create a traffic to have a packet forwarding activities in your activity history. It's not earning anything. The idea is just to see your activity every hours. Because I mean, when you are doing POC, particularly nowadays where there is only 1 or 2 POC per hotspot per day, you can have 8 hours with no activity in your activity list. And so you say, okay, is the chain is not working? Is my hotspot is not working? Is that normal? I don't know. I'm afraid I have to reboot.
So no, not reboot.
It's a little bit painful. Yeah. So personally, to see what is happening, I'm sending traffic over the network, and so my activity always has something. So if I don't see any activity since 2 hours or 3 hours, there is 2 possibilities. The first one is the chain is blocked and, and stuck. That's the main one. And the other one is my hotspot is disconnected to the chain. And so that's a good way to monitor if the hotspot is working correctly. As there is, I mean, something that could be missing in RAK, for example. I mean, if I compare to with Nebra, where there is a dashboard, you can see your hotspot status in RAK. It would be really cool to be remotely see what is the hotspot status. I mean, the API, the Explorer should do that, but trust we can have in Explorer. That's
always broken. It's
yeah, currently it's it's gonna be fixed, I'm sure, but currently it's a bit complicated. So that's, I mean, that way I can have my monitoring. So I have this tool I'm doing. It's, I mean, if people are interested, I sell it through shop.ingeniousthings.fr. You did not prepare that one, Maria. So you can take a look. It's really a simple device. And the other one project I'm working on is that field tester I talked a bit about previously. Which I mean, basically allow to when you are moving in your city, it will send a message to the hotspot around, and it will get a response from the hotspot. So you can measure the signal strength on the screen. So you have graph bar with a signal strength, which is cool. But it go further. I mean, this message also goes to a server in backend, and so this server is backend respond to the device with the information about the signal strength seen by the network. Currently, there is some bug in the router, but later on the screen, when this bug will be resolved, you will see the number of hotspots that has been able to receive the message from a location and the signal, the minimal and maximum signal power for this. And that's quite interesting, because if you are looking for a good place to deploy your hotspot, you measure, and you see, oh, here I can touch 8 hotspots. I'm changing to another place. Oh, here I can take 10 hotspots. Oh, that's a better place. So that can be interesting to see what is the best place to deploy network. And there is a third thing which is interesting in the device. It also has a GPS inside. And so with the GPS, you enrich the mappers.helium.com, so you get information about the coverage. And that's quite important, because, I mean, if we want to have people using this network, we need to have the network installed, but we need to make people know what is the coverage. Because people who is we're thinking about an application, need to know this application can work correctly in the area it has to be done. I mean, an example. Today I talk about tracking solution. Currently in Clermont-Ferrand, so my city in France, you can take a look to the mapping we are doing. We know that from the south of the city to the north of the city, we have a full coverage. So for example, if you are a buses company and you want to track the buses, to have a real-time alert on buses arrival, to predict the time of arrival, to predict the late and so on buses, you know with that coverage that you can use Helium network to do that, because of coverage for the whole city is 100%, or quite 100%, and you will be 100%. So that's really interesting, because if you want to propose such service to the buses company, you can show the buses company the map, and you can say, hey, we have a network. You see that the coverage is good for everywhere we need to be. And now I can propose you an interesting solution to put in place and so on. So the mapping is something quite interesting to do. And so that's why I've developed this project. So this project is fully open source. It's on my GitHub. You have everything, the PCB JRBR file, the casing, the list of products, the source code, and so on. So you can get it. I also in my shop sell some kits. So just to avoid to buy the component by yourself on 10 different shops and just getting the kit to assemble yourself. So you can take a look at this also. And in terms of application, I also have a cool one we can talk about, because it's based on RAK system, which is my garden monitoring. Maybe I can share my screen for this, because as I open, sharing, talk. Sharing. Okay, you should see my screen now. And so here you have, sorry for the scrolling. So here you have the system. It's a big hack make in about 1 hour, thanks to the WeBlock stuff. You see my sensor, I have a really nice soil moisture sensor with big screw, and what is really cool, I mean, I do that with WeBlock. In fact, I had thank you, Jose, you give me a WeBlock for testing it. That's really cool. And so I had this WeBlock, and I was looking for something cool to do with that, and my boy did he had a garden where he's putting, he's trying to get some vegetable and so on growing. And the question is, when do I need to put some water on that garden? Mm-hmm. You have to think about it every day, but not putting too much and so on. So when do I need to do that? And so I had this RAK kit, and I've seen on RAK the cool casing with a solar panel. And so that was something cool to say, well, I could do something really easily outdoor. And so I get all that stuff, I assemble all of this. It's super easy to make the code on it, because just one sensor, which is basically just getting a soil moisture with a measuring current, voltage between the two big screws. And so that's it. I also have the sensor with the environmental sensor with the temperature, hygrometry, and pressure. So I use it also, but it's super simple. If I can go back on my share screen. Yeah. So that's it. What is cool is, I think that most of the people here know the WeBlock, but for me it's kind of Lego for IoT. So it's really cool to assemble. So you see that inside the system, I have the motherboard. On the motherboard, I have the MCU, which is able to communicate on LoRaWAN, so on Helium. I have the environmental sensor here with temperature, pressure, and hygrometry. And I had the extension board, the Grove extension board. It was just to get an analogical I/O. Basically, that's it.
Right.
Mm-hmm. Yeah, I don't use another I/O. And so the assembly is quite easy. So as you can see on the screen, and maybe on the screen is good. It's really well done, and I've made something really cool with two big screws passing through the system. You can see the post-it. You see the post-it add-on to be sure. The screw does not touch the sensor does not touch the screw. So that's quite important. And here, as I say with Maria at the beginning, there is one thing which is missing in the kit. You really have to provide the screws, because you see that I've used this big, I don't know how it was. I mean, you see spacer. I have to use this big spacer to be able to fix the board in the box, and so that's why I had a problem with my sensor here touching the only place where I've been able to put a screw. So,
Wow.
and some scotch. You need post-its when you do a good act. You need post-its and duct tape also.
Good tape. Yes.
Yeah. So there is no soldering at all on this system. It's just
Just a lot of tape.
screwing, and after it's
Oh
duct tape and so on. So
I'm not sure that's the spirit of WizBlock, man. I don't know. It's not the idea we had in mind.
You can do it. You can also do it with Block. So after the code is really super easy. It's open source also, so you find the code on my GitHub. I don't know if there is some code sample, but I mean it's you just get waking up on a regular basis, getting the status on the different sensor, and create a frame with that, and the frame is sent through Cayenne. So the format is a Cayenne LTP. So basically, it's a format of data where in the payload you also indicate what kind of type of information you are sending. So if you send a temperature, for example, you put a 01, for example, then you put the temperature in a certain format. And at first you put a sensor number, so maybe 01 also. And so when you send this payload to the Cayenne dashboard, automatically Cayenne knows that it's a temperature. And so it can select the right widget to display it. Mm-hmm. So I've used that because it's just a 1 minute dashboard creation. So here is all the detail. And so just I want to share the Cayenne the Cayenne dashboard to show you what we get with this. I don't understand in Cayenne because you have a public dashboard, and after a while, on the public dashboard, you have to log in to access the public dashboard. It's okay, strange. So here you have this dashboard. So you can monitor. If you click on the link, you can monitor my garden from internet. So you can send a text message to my son, asking him to go to put some water in the garden, if you want. But we also get an email. So currently you see that it's 15%, which is quite normal because it's there. So it's dry. But if we take a look to the chart history on the current week, we had a lot of rain this week. Copenhagen is a bit slow, but it's gonna arrive. And so you see here you have the trace. So currently we had a lot of rain, so we are near 100%. I mean, we are 80 something. Here, just before the talk, I removed it from the garden, so that's why it's to the point. When you see that we had some day where it had been a bit dry, and here my son put some water in the garden, so you can see that he has act for this. And after we have the other information like the air temperature, air humidity, and the barometer also information. So it's quite cool. And I'll say what is cool with this project is, I mean, it really has been a 1 hour hacking. I mean, I spent 1 hour to do that with my son, so it was quite a good time, and it's super easy. So that's cool. And also, other thing I can add, because I mean, it was a good opportunity to get the system out and do some measurement. It's solar powered, so I mean, my garden is not correctly well exposed to sun, so I think there is 2 hours of sun per day. Basically, it's not really good for a garden. that's it. And so I was a bit afraid also about the solar powering solution. And basically, I measured it's more than a month that is deployed, and I measured the LiPo voltage today, and I'm more than 4 volts. So I mean, the system is always always on, no risk of running out of battery with it. So it's quite cool. It's quite cool.
Trying
You
to
like
make things
it, Jose?
completely autonomous.
Yeah, fully autonomous through thanks to the sun powering. So that's good.
Yeah.
And the box also. I mean, we had a multiple storm this week and so on, and I mean no issue with water on it and so on. So it's really good. I had to add some duct tape on the top on the USB part because I was not really confident with the system. And basically it could have been under, so it would be good, but under I have the screws, so that's I prefer to put some duct tape, but I mean it's really worked well like this.
Excellent. Very good project.
Very good. Thanks for sharing it. Nice. And we have a question over here. I'm going to place it. Hey Paul, love seeing you on all this segment. Helium Hats was great. Any kind of difference have you seen with IoT sensor as in distances they can reach as a locator compared to their sensors?
So difference of distance they can reach. I mean, in terms of performance. So I don't understand what we try to compare basically. So if it's a Helium versus another LoRaWAN system, or if it's a WizBlock versus some other solution. But basically, I mean, LoRaWAN is LoRaWAN. So being Helium or being another one, it's the same technology, so that's the same distance. In terms of radio performance, if we talk about the WizBlock, the question is just the antenna. I mean, here we have really a simple PCB antenna. So in terms of performance, I'm not sure you can reach 10 kilometers with such antenna. But I mean, it's a SIP connector, so you can put any kind of antenna, and if you want to reach 10 kilometers, you just have to use an antenna like that one, and that's it. So in terms of distance, I mean, we can. That's quite interesting. After I mean, in terms of distance, what we see in terms of deployment. So I mean, the POC are interesting to see the distance we can cover with the network, basically. And currently, I mean, we have some 20 kilometers POC in your city. So yeah, that's really good performance. I mean, but we have in a lot of mountains, so we are in a good situation to make some big distance like this. But it's worked really well. Yeah.
Super nice. That is the only question that we have on the comment section. Just like some say hi's and comments about the price of the DC and the packages, and that's it. So I would like to jump as well, like in my last questions. We are already out of the time. But I would like to highlight this one, and is that what advice will you give to those individuals who are deploying hotspot and they wanted to do in the most optimal way? Like any recommendation, you share some upgrade you have been doing for mapping this kind of stuff, or if you have any other recommendation on hardware or software tools to analyze the best hotspot deployment that you would like to share, they are completely welcome.
Yeah, I think that's what is really important is the collaboration between the different people doing the deployment. It's something really great we have done in Clermont-Ferrand, but I mean also in France, where we have a community about 1,300 people currently discussing on Discord. We have created maps of hotspots with the existing hotspot, but more important, the coming hotspot. So that's something really important. That way, we can find the right place to put the hotspot to have not a too big density and not being too close the one to the other. So that way, I mean, if someone wants to add a 3 place to put hotspot, if one of them is in the middle of 3 other, he will prefer to put it in another place. So that way, it's more efficient in terms of network deployment, but it's also better in terms of network coverage. So that's the most important things. We also have a lot of discussion of what kind of hardware you need to have, what kind of installation. We are sharing a lot about hardware, or the difference between a rack 3 dB versus a 5.8. What is the regulation? What kind of cable we can do? Is it better to be on a balcony or on a roof? So we had all this discussion. We also share the different tools to do the radio estimation, so radio simulation, so people can do some trial and see what is the impact of their choice. And so that way, when a gateway is deployed, directly it is installed with the right settings. Most of the gateways that are deployed in Clermont, they are deployed with rack antenna correctly exposed and so on. And so the performance is really good. I see Christophe in the chat. Christophe is making a map of the city with all the weaknesses. And when you take to that map, you see that most of our hotspots are seeing all the hotspots basically.
The cluster,
and we have a 1.00 reward scale for all the hotspots. So that's really currently it's really performant in terms of coverage, and it's really performant also in terms of mining revenue because there is no reward scale, and we have a maximum number of witnesses in our configuration, which was not really easy. I mean, we have advantages of having mountain around. So if we put a hotspot on a mountain, we have a really good coverage. But we also have mountain in the middle of the city. So if you are in a south, it's really complicated to see the north. And in fact, it works better than I was expecting at the beginning for certain. And so that's quite interesting. So what is really important in terms of performance is antenna. That's really the key point. I mean, in terms of, I did not do a radio test to see if a neighbor is better than a rack or rack is better than a Bobcat. I don't know, basically. And there is a regulation, so basically they should be equal. But the antenna is a key point. I mean, the antenna that is provided with the hotspot is, no interest in terms of radio. It's just for decoration. You need to have a real antenna, an outdoor antenna, even if you have, just one second. No, shit. Even this outside. If you put such antenna outside, normally there is a magnetic part under, but it did not come. If you put that outside on your balcony, it's going to be 100 better than just % better than getting this inside. So that's the key point. And the recommendation is really to go to fiber antenna like the RAK 3 dB or 5.8. The problem is currently there is the same difficulty to get RAK antenna than hotspot. It's really complicated. Oh yeah. When I tried to order some recently, they there is a quite long delay, an unusual delay to get them. So anticipate. It's anticipating is important. And after in terms of tuning, such tool is quite also interesting to find the right place once the network is deployed and to do the mapping, as the mapping is something, as I say, which is quite important. I can just share, if you have a couple of minutes, the mapping in Clermont-Ferrand to let you see what we do. And for mappers, it's also interesting if you like, if you want to hack a bit on IoT. Just sharing my screen. Yeah, shared. If you want to try to develop a bit on IoT, it's a cool project to do. Wow, I'm super slow. My network super slow. It's something really cool to do to make your own tracker and own mapper. Also talk about Christophe, but Christophe has made a project with TTGO. You can also do something with a rack with block, adding a GPS on it, and so on. So it's a cool project that is, efficient. You can see the power of the network by doing this, because you can connect it to cargo and see your trace. You can create the mapping information and so on. So that's quite cool. So here is the mapping.
Nice.
So this is what we get thanks to this kind of devices by reporting location to the mappers. And this is the mapping of our city. So you see that basically the city is in the middle. And all around here, all around you have mountains, basically. And currently we go to the north, and we had a trace, but it was not connected to mappers. But really on the top of my screen here, you have a city, which is Helium.
Nice.
And this city is also covered through the different hotspots we have. So that's quite interesting to see that. We have, I mean, if I compare to what we did, we also continue to deploy the Sync network. Also, this coverage is the one we had on the Sync network. I mean, this year after 5 years of deployment, and so now we have it in Helium in less than 6 months. And I think that in 2 weeks the coverage will be largely bigger with Helium, because we are deploying Helium in some radio tower in the mountain.
Nice.
Wow.
I mean, the difference is we can pay with Helium. You know, you can go to see a radio tower owner, and you can propose him some money to get a space.
Nice.
Yeah, what you cannot do with the Sync network, you have to convince him to give it for you. And so we are covering the city, but we are also covering behind the mountain. So we are also covering all the countryside around, so which is really cool. And so I really hope that we're going to be able to join the different cities that way, which is super important when you want to have a tracking business, for example, to have not only the cities, but also have the point between the cities. So nationwide network, which is the challenge. I mean, the big challenge for Helium is being able to be nationwide. And that's, in my point of view, the big challenge compared to national operators that are nationwide for those who have deployed nationwide. In France, we have 2 of them, which is really rare, but we have it. And that's a challenge, how the chain will be changed, its transaction and its reward, to push them to extend the network outside the city center. So that's quite interesting.
Super.
Did I miss something? Did I miss something you have in mind, Jose?
You've talked a lot, man. Yeah, Helium is like never ending. Like once you go deep, it never ends. I mean, maybe mention that, like, when you say pay, it's not really pay. We're burning tokens on the blockchain, so we're not paying anyone. It's just adding more value to the HNT token.
Yeah.
And do you know, like, if you run your own hotspots and you run your own router, do you actually pay for any data credits in the end, or does it cost money?
Yeah, I mean, yes, you pay because, as I explained, the router, you have some transaction like state channel, like device registration, and so on. And so this one are paid, and there is no revenue in front of this. So for the DCs, if you have your own hotspot and your own router, I mean, basically you should just pay DCs to yourself. But for that transaction, you have to pay.
You have to pay those.
Yeah, you have to pay. So there are, I mean, it's if you have a bad parameter, it costs you a lot. But if it's correctly a parameters, I mean, it's something like 1 million or I mean, at a maximum of 10 millions per year. In 10 millions DCs, it's about $10 or
$10, yeah. So it's not not a huge amount.
Yeah, that's not a big. Yeah.
Interesting. Cool. Nice. Thank you.
Okay, I think that's all for today. No more questions on the chat. No more questions on our side. Paul, as always, thank you for joining us, for sharing all your experiences. We are super happy to learn with you and to see all the contributions you have been making to our community, as well to the Helium community. And as always, we hope to see more things coming, and we are going to keep track of everything. So
Yeah, for sure.
Some more in preparation. Stay tuned.
Yeah, completely. So yeah, that's all for today. If someone is watching this video later, feel free to leave your comments on the section. And if you have any doubt, we will super happy to address them later. And we hope to see you next week in another session. Happy hacking, folks. Bye bye.
Thank you. Bye
Thank you,
bye.
Francine. Have a good weekend. Hope you talk to
You
you soon,
too.
Maria.
You
Bye
Bye.
too.
Bye.
bye.
Bye.